So, hello everyone. Today we again continue to work and prepare ourselves for uh, practical part of any technical interview, especially for fun companies like Google. And today we will check an exercise which is called clone graph of type medium. And the idea of this problem is that we need to copy an already existing graph while correctly preserving the order and values of the nodes. And actually this task is pretty similar to the previous one, which we have resolved. And in that, we also will use BFS in order to solve it, meaning that we will traverse each node breadth first and make a copy of its nodes that we have passed through will be marked as visited to avoid recursions. So that's the main idea. We will use BFS, we will pass through neighbors, we will mark already visited like visited in order to avoid recursion, so that's like a small summary. And we again need to keep the order, so you can see that, for example, here we have initial graph, so results should be exactly the same. So here we have an example of graph which is not valid, so it was copied but not correctly. So that's the main idea. Now let's check the implementation of this algorithm for that task. So let's go and try to solve it. First of all, let's define a node. So let's create a class, inner class, which we will call node. And here inside we will have two parameters. So first one will be for a value. We will store the value. In our case, it will have int type. And also we will need to have a list of nodes which will represent our neighbors. So let's create it, list node, and let's call this list neighbors. Yeah, perfect. Now let's create a constructor for this class. We will call it also node, of course, and we'll have a parameter which will be our value. So in order to initialize our value, and neighbors will be new array list. And also let's create another constructor with parameters. In that case, we will have both parameters, one for value and second one for our list of neighbors. It's not neighbors. All right. And also we will need to create a map. This map will contain visited nodes, and in case if we have already visited the node, we just will return it from that map. But if not, we will need to create a copy of this node and to place it inside this map. So let's do this. Private final. Node. Let's call it visited. Oops. New hashmap. All right. So when the important part is behind, and now let's create our method, which we'll call clone graph. We will return a node it will be the starting node, yeah, which contains his neighbors. His neighbors contains a list of their neighbors and so on. So we'll return a node and we'll call it clone graph. Like argument, we will have initial node which we wanna copy, which we wanna clone. And the first thing which we wanna do, we wanna to validate that this node is not equal to null, because if it is, we just need to return null because we don't have anything to clone. So let's put here first validation. Let's check if node is equal to null, and if it is, we just will return null. Perfect. And let's create another method. We can actually do it inside here, but just for visibility, our def_fast method. So our def_fast percussion through this graph. So let's do this private. It will be private method, not. We'll call it def_fast depth first search. And here inside we will have one argument, our node current. Alright, and here inside we will call this def_fast method. Here we will put initial node, which will pass through all nodes. And we'll make a copy, and then the result will be the initial node, which contains in a list his neighbors and so on. Now so this method will be called recursively. So we first thing about which we will need to think is when we want to stop this recursion, because if we don't have this condition, the recursion will be executed infinitive times. We don't want to do this. We want to stop it in one point. And what point? So we will stop in case if we have in our visited map the element. So if the current element was already visited. So if it was, we just return it from our map. If not, we need to create a copy of this node. But how I already mentioned, if this was already visited, then we just return what we have inside our map. So let's do this. Let's check if it was visited. Current. And if it is, we just need to return the copy of this node, which was stored inside our map. Current. But in case if it wasn't visited, we need to create a clone. So let's do this. Clone. New node. And here we will place a value. Current.value. Alright, but also we need to copy, we need to make clones for this current node, yeah? And for that, we will need to call this method for all neighbors for this cloned node. But before doing so, after we have created the clone, we need to add this one inside our map. And doing so, we will mark it like visited. So let's take our visited map and put that the current node was already visited. So we will place it inside our map, and if we'll reach this node, we just will return already cloned node. Perfect. And now let's call recursively this method. So for all neighbors for this node, let's call this def_fast method. Neighbor. Okay, and now we will need to, so when this DFS will be executed, it will return the clone of our neighbor. Now we want to put this neighbor inside our list, inside the list of the current node, which we already cloned. So let's call clone neighbors, and inside the list we'll add all cloned neighbors. And in the end, let's return, so let's return the clone. And that's the solution. I hope it was clear. I hope the implementation is clear for you. If no, please write a comment and I will try to help you. And now let's check the complexity for this algorithm. So the time complexity will be OV plus E, and the space complexity will be OV. So that's how we can solve this kind of exercise, and I hope we will see in the next video. Bye.